Alright, well, good afternoon. It is section 5.7, multiplying fractions. And what I want you to do first is go ahead and hit pause and write this information down. So the rules for multiplying fractions says, number one, you are going to multiply the numerators together, then multiply the denominators together. Simplify your answer is step 2. So as you can see, that's about as easy as it gets. It's a nice change from adding and subtracting. So you're going to simply take 2 times 1, which is right here listed, and then 3 times 4, which I have here, and 2 times 1 is 2, 3 times 4 is 12, and yes, you must simplify now by dividing each of those by the greatest common factor, which is 2, and you get 2 divided by 2 equaling 1, and 12 divided by 2 equaling 6. So that is the extent of what we're doing today. So let's go ahead and try some. Go ahead and multiply 1/2 times 3/5. Go ahead and hit pause. Now, as we did in adding and subtracting, we would stack them on top of each other like this. And today, don't want you to do it in that manner. Now, we want to leave our multiplication so that it is horizontal, and you're going to see some steps why we want to do that. The biggest reason is because you're multiplying numerators together, denominators together. We're also going to do some possible reducing, which we call cross-reducing, before we multiply in some of these situations. So to solve this, again, it is simply taking 1 times 3 is 3, and then 2 times 5, which is 10. Now we have to decide whether these are in simplest form or not. Sometimes they will, sometimes they will not. And 3 is prime, so if 3 doesn't go into 10 equally, as it does not, then it is in simplest form. So let's go ahead and look at the next problem. Go ahead and solve this. Alright, so we can take 2 times 5, which is 10, and then 3 times 6, which is 18. They are both even numbers, therefore we can divide by 2. And 10 divided by 2 is 5, and 18 divided by 2 is 9. 5 is prime and does not go into 9 equally, therefore that is my final answer. Now I will tell you there are some shortcuts, and it is called cross-reducing. It is dealing with our diagonal numbers. Okay, so it is dealing with just our diagonals, the relationship that they might have. And 3 and 5, those could not be reduced. But my 2 and my 6, both of those, these right here, do have the capabilities of being reduced. They're both even numbers. So if we were to take 2 and divide it by 2, we can cross that out, and that becomes a 1. And if we take our 6 and divide by 2, we can cross it out, and it becomes a 3. Okay, that is what we call cross-reducing. And then 1 times, we take these new numbers now, and they are replacing these numbers that we crossed out, and 1 times 5 is 5, and 3 times 3 is 9. So you can see the number that we reduced at the end is the number that we're reducing before we actually multiply. Okay, this will be something that we are going to want to make certain we know and understand, because it will help us in having to reduce really large numbers at the end. So you can also cross-reduce not just one set, but you could possibly both of the diagonal numbers could reduce as well. So let's look at the next one. And I'm going to let you hit pause and see if you can solve this. So we take 3/5 and multiply it by 4. Well, that's a whole number. So how do you make a whole number into a fraction and not change the value of it? Well, you simply take that number and put it over 1. Because isn't 4 divided by 1 4? That's how we do it without changing the value of it. So now we look, are there any ways we can cross-reduce any of these numbers compatible? And they are not. Therefore, 3 times 4 is 12, and 5 times 1 is 5. Now we have an improper fraction, so we're going to have to reduce this. So we ask ourselves how many 5s go into 12, which are 2 wholes, which gives me 10. And 10 from 12 is 2, and 5 remaining. So again, that looks like this for our reducing. Goes into it 2 times, which is 10. Subtract 2 left over, so I get 2/5. Okay? Let's take a look at our next problem. And again, I kind of jumped the gun a little bit, simplifying before we multiply. And you can see here when we have 3/4 and 5/6 that we can reduce using cross-reducing. 3 goes into 3 one time, and 6 divided by 3 2 times, and you multiply 1 times 5, 4 times 2 to give me my new number. Otherwise, we'd ended up with 3 times 5, which is 15, and 4 times 6, which is 24. Just a lot bigger numbers instead of using smaller numbers like 3 and 6, numbers that are a little easier to see the greatest common factor in. So let's look at doing this next one. Go ahead and do letter F. And yes, you do need to use cross-reducing, and please look at both diagonals. They might both be able to be reduced. So go ahead and hit pause and solve. So we look at my diagonals, and you can see 3 and 3. Well, what divides into 3 and 3? 3 does. So you can divide both of them by 3, okay, which is 1. And 3 divided by 3 is, again, 1. 2 and 8, finding an even number, 2 does go into them. So we're going to divide both of them by 2, which gives me 1 for this. And this divided by 2 gives me 4. So now you use your new numbers, 1 times 1, which equals 1. And 1 times 4 is 4. Still take a look at this number, because sometimes it still will need to be reduced. So please double check. You always want to make sure that final answer is in simplest form, and indeed this is. So please again make note of anything that does not make sense to you, possibly the cross-reducing, and we'll talk further about it tomorrow. Have a great day, and we'll see you tomorrow.